If you've worked on a lathe before, you'll know that parting off is by far one of the scariest things to do. What makes it worse in a home workshop is you can't sort of grind every single parting blade to the specific material that you would typically use. There's a few issues with this, but we'll get to that a little bit later. I've found that the biggest problem with parting off is getting the tool jammed, and this video is going to deal with all the different tricks and methods that I use to prevent that jamming, and also how I sharpen and maintain my tools and align them in the chuck. I'm also going to go through some interesting other ways of parting off rubbers and plastics and stuff like that. This is typically not shown in normal videos, and I'll add it to the end of the video. So if you're interested in parting and you want to find out my little tricks and trades and how I get around all the problems, then this is the video for you. But let's start with just the basics, setting up the parting tool and grinding it. I don't think anyone will argue the importance of sharp tools. But what people don't tell you is if it's a mission to sharpen your tools, you're not going to sharpen them. So the idea is to have your sharpening system right up close to your lathe, so you can literally take it off your quick change tool post, quickly put it on the grinder, check that it's sharpened like you want it, and then within a few seconds put it back onto your quick change tool post, and then you're ready to go. Some people recommend making the tip of your parting off tool slightly angled so that you don't get a tip when the part comes off of the bar stock. This is a bad idea for the simple reason is if you slant it, the chip that comes off inside the slot is actually wider than the slot itself, and you're just adding to the chances of that whole system jamming up. So I have one or two parting off blades, and on the one side I grind them for mild steel and stainless steel. This is typically a 10 to 15 degree relief angle from the top side. What is incredibly important for any relief angle on the top is the chip needs to slide off of the top without jamming and without any appreciable resistance. So this surface needs to be unobstructed without a step, and it needs to be well polished. On the other side, I grind a 0 degree relief angle at the top, and that I typically use for brass and plastics. The front relief for both sides is around 8 degrees, and this is a good rule of thumb for most high-speed steel cutting tools. My setup for grinding the parting off tools is actually very simple. A lot of people use the front of a simple wheel on a bench grinder, and if you put a card up against the edge of the wheel and you line that up with the tool, you'll get more or less the relief angle that you need. I tend not to go this route for the simple reason is you get a bit of a concave below the very tip where you're trying to hold the forces from your cutting. So on my system, I use the side of the wheel, which gives me a straight edge underneath the tip that works the most. And also I can set up my little bench grinder and it'll stay there and never be touched or used. And the front end can be used for my other high-speed steel tips. Okay, so let's assume that jamming of your chips inside of the slot is one of the major issues with parting off. Everyone would agree that the stiffness of your tool post and your taper slide and your cross slide is incredibly important, because if this tool slightly shifts to the side, you're going to get a jam. If you have your taper slide at 90 degrees, like so, there's a couple of issues with parting off like this. Very simply, your two bolts are right in the middle of your cross slide, so they're the furthest away from your dovetails. So if you look at the bending moment, you're bending the middle like this. So this is the weakest point of your cross slide. Another problem is if you're parting off
sort of slightly smaller diameters, you need to go slightly further. So now you've lost a bit of your travel. In other words, if you have a look at your cross slide, now your dovetails aren't engaged along the full length. So again, you've lost a little bit of holding force in this whole system over here. What I typically do is I turn my taper slide to roughly 55 or 60 degrees. Now I do it 55 or 60 degrees because this is how I cut screw thread and I feed in that direction. But we'll get to that when I do that video. Another thing is, if you're on your 55 or 60 degree like this, now you can turn your quick change tool post or your turret tool post, and you're actually on a corner of your taper slide. So this is a stiffer configuration than what it was before. One of the benefits of this is your taper slide is actually out of the way of your levers. So this makes screw cutting a lot easier. But okay, we're dealing with parting off. You'll also notice that now we've gained a whole sort of 5 or 10 mils depending on how big the thing is. And now we can use more of the dovetail. Again, an added advantage is the bolts are closer to the dovetail, so there's less of a bending moment, and also your two bolts aren't right in the middle of your main cross slide. So again, all of this stiffens up this whole configuration over here. So just by having a look at how this is all set up, you've stiffened up the whole system and you've improved the parting off capability of your lathe. And before I forget, obviously each thing needs to be tight. Any movement over here is going to end up in disaster. So without any argument, all of these bolts need to be tightened. And I have on one occasion forgot to tighten one of these bolts, and immediately the tool jammed. Specifically this bolt on this side of here, if you forget to tighten that, you lose the stiffness in this direction. So all bolts need to be properly tightened. So setting up the correct angle and so forth of the parting tool is relatively easy. I typically use the jaws of the chuck and I just align it so that I cannot see the paper underneath. So then I know this direction is correct. The height of the parting off tool is typically debated quite often. Some people say that the height of the parting tool should be lower than the center line. I don't agree with this for the simple reason, if it's too low, when you're parting off, whatever you're parting off is going to climb onto the tool and it's going to get jammed between the base and the stock that's left. So I generally don't like doing that. But if you go too high, then you're actually not getting a nice clean chip, because you're sort of wedging and you're grinding and you're damaging, you're not really cutting. So you do have to be on the center line or a fraction below. Thing is, how low is below? Personally, what I typically do is, if I have a pointer inside my lathe like this and I adjust the height of the parting off tool, I do it so that I can still see the tip of the pointer. As long as I can see the tip, I know that I am a fraction below. Then I know that I'm not going to grind away at the cutting edge, and also I'm not too far below so that the part, when it comes off, is going to climb on and jam. Very often I've machined something and I don't want to take it out and I want to part it off. This is typically when you're parting off. It's the last operation. So you don't want to set it on the chuck itself. So what I do is I have a setup like this where I can go and take a pointer and I can check it away from the job and adjust the height like that. This is much easier, and then you don't need to take whatever you're machining out of the chuck. And that is the easiest way to set up a parting tool. Alright, I think it's time for a practical example. I have checked that all the bolts are tight on my lathe, the taper slide is tight, the tool height is correct, and everything should be good to go. I'm going to be cutting a 3mm washer, and it doesn't need to be that accurate, but because it's got a chamfer at the end, lining up the end of the parting off tool can sometimes be difficult. One of the easier ways to do that is to just line up a ruler, and if it touches at all points, then you know you're at the end of the job. I'm going to move the parting tool 3mm. 1, 2, 3. And this is quite important. I'm actually going to zero my parting off blade. Now what I'm going to do is I'm going to plunge at roughly half the speed that I would normally cut that outside diameter. I'm also going to apply a little bit of coolant. This is for two reasons. It cools the tip, but it also applies a little bit of lubrication for that chip to get out of the slot. Now what you're going to see is you're going to see the chip starting to curl, and the minute that curl starts getting jammed in the slot, then I'm going to reverse the tool. I'm going to move the tool slightly in this direction because we want the actual washer. We're not interested in what's happening on that side. So we're going to widen that slot a little bit, and then we're going to cut a slightly bigger groove. And then right at the end, I'm going to pull back, and then I'm going to face off that on the inside, face off the end of that washer, and then finish off the parting. In that way, your slot is always bigger than the chip that's coming off, so there's very little chance of jamming. You'll also notice that I have a welding rod that I'm sticking inside the hole of the washer. I do this I generally do this when there's a hole, and it actually works quite well because what happens is when the part comes off, it doesn't fall into the bed and get lost, and also it comes off and it's not going to hit the tool or get jammed in between the workpiece and the tool, and then it just rolls off onto this welding rod out of the way. So this is quite handy. If you're doing multiple parting off tools and you don't have a chamfer, then this actually becomes quite handy because you just part off and each time it drops onto the welding rod, and then right at the end you just take them all off. Okay, but enough said, let's get to parting off. So that over there is typically my machining speed, and I want half of that. So that will give you an idea of the difference in speed. So I do not use auto feed, and there's a very good reason for this. While I'm parting off, I'm listening to the machine and I'm looking at what that chip is doing. If it starts giving me a little bit of feedback or a little bit of grinding, then I know that I need to move the tool slightly and I need to start opening that slot. So that slot gets opened, but I don't part all the way to the hole. The reason being is I want a nice finish on the washer. So right at the end, you see that little curl that formed there? I immediately pull back, because if that curl gets stuck in that slot, then that's a jam. So let's move this back to 0. We're on 0. And now this is finishing off this washer. And now the curl that's forming inside there has got space to move and get out. So I'm not too worried about it because that slot is a lot bigger. But the minute that I feel grinding or anything like that, then I'll pull back. And there we go, a nice washer. Okay, so I've already introduced you guys to my standard everyday use 2.4mm parting off blade. It's high-speed steel, and this does most of the jobs, but I do cut other sizes. A general rule of thumb, and this is really a general rule of thumb, just a guideline, is the parting off tool thickness should be roughly 1/10 of the bar thickness. So if you want to part off a 10mm bar, you should be using a 1mm parting off tool. So then by inference, the 2.4 would be roughly 25mm. I also wouldn't let the parting off tool stick out more than sort of the radius of the bar. So if I'm cutting a 20 mil bar, it would just stick out more than 20, so on radius, so roughly 11 mils. And you really don't want to go too far out, because then you end up with too much flex on your bar and you could end up with jamming. That's why if you cut thicker bars, you need a thicker parting off tool. Generally for the home workshop, I wouldn't really go bigger than sort of a 30 mil bar, and the 2.4 millimeter parting off tool will just do that. One higher and your cutting edge becomes very broad and your forces actually become a lot bigger. So what do you do with the smaller sizes? Because this is a little bit rough to cut, say, a 6 millimeter bar. As you're cutting on almost a 3 millimeter cutting area on a 6 millimeter bar, there's quite a lot of forces, and you could end up with a bar climbing on right from the beginning. So then typically you want to use a 1 millimeter or thinner parting off tool. Now I'm not going to go buy another blade. I'll buy one or two of these, and these are everyday use. You can actually make your own parting off blades. So I use these slitting discs quite often, and they don't really last that long. The sort of teeth break and stuff like that. And you can't use it in this state, because if you hit a corner, then this will stop the machine dead and you damage your job that you're busy with. What you can do is you take one of these discs, you just mark it, top and bottom, and then you can make yourself a nice little parting off tool just by cutting it with an angle grinder and then finishing it up on a grinding stone. This is what I did for this parting off tool. So this holder I actually made myself. It's a very quick and easy parting tool holder to make, and you can blacken it with a little bit of oil, heat it up red hot, and you dunk it in some oil and it will come out nice and black like this. This is just one of these discs that have been cut off, and this makes a beautiful parting off tool. If you need to go even smaller than that, you do need a little bit of meat behind it. And what I do then is I take a piece of mild steel, silver solder a broken piece of, in this case it was a 3 millimeter slitting saw disc. I solder that onto the mild steel, and then I grind it to the point that I'm looking for. Now this is an incredibly fine point that I use for slotting circlips. So that is about 0.6 millimeters in width, and then you get a nice groove for your circlips. This works incredibly well, and because you have a nice high-speed steel, quite a thick one behind your tip, it actually lasts quite long. Now right at the beginning of the video, I promised to talk about cutting plastics and rubbers. There's a nice trick to do this. I normally take a Stanley knife and I take the disc, or not the disc, I take the Stanley knife blade and I mark the bottom of the blade. I cut the bottom off with an angle grinder, and then that goes right into my standard parting tool holder. Now just a little note on safety, and I hate safety in videos because safety belongs to the person that's behind the machine. So any safety advice that I give in any of my videos will be specific to a very odd tool, and it's not something that sort of a person would think of right from the beginning. If you have a knife blade like this on your tool post, it is a hazard because you're working around your chuck. There is a very good chance that you're going to slit your hands, or even worse, your wrist. So whenever I use a tool like this, that is a very sharp tool, it only goes onto the tool post right at the end just before I'm going to use it. And the minute that I'm finished with the job, it comes off of the tool post and onto the stand. So this will never stay on the tool post for any length of time other than what is being used. And I will never work around the chuck or the tool post with one of these knife tools in place. Then one last thing. These tip tools have become relatively cheap over the years, so a lot of people have started to use them. I do have one or two of these tip tools. In fact, I only have two, and they work reasonably well. There is one thing that you do need to have a look at. If you have a look at the way that the chip comes off of this tip tool, this clamping at the top here forms a dead stop for the chip coming off. So if you can imagine a chip coming off, it's going to hit that stop dead on and your tool is going to jam in the slot. So I haven't done this to this tool because this is straight out of the box. But what I do normally do is I just take that corner over there while it's on the tool. I take a Dremel and I just make that a nice, even sort of radius. So this little part over there, this top clamp gets ground in place, and just so that any chip that's going to hit it is going to deflect up and it can clear very nicely. You can't take off too much, obviously, because this clamping is holding the tip tool down, so there is a bit of force there. But what you can do is you can just even it out nicely so that the chip can clear. I think my knife parting off tool needs a little bit more of the limelight. This surprisingly gets used quite often in my workshop, and it gets used for the oddest jobs. Often I need to make seals for stuff on my vintage motorbikes, and one of the most annoying seals that I have to make, and generally they're very difficult to find, is the petrol petcock seal. Now, in the old days, these seals were made from cork, but cork disintegrates and it doesn't last very long. So I replaced these seals with normal petrol line, and I find that they last a lot longer. What I also do is, this petrol cock hasn't been changed in any way, but what I normally do is I machine the whole back end off, I drill and tap, and then this becomes a compression gasket. So I put a seal over here, I tighten the end, and then this thing expands and seals a lot nicer on the outside of the petrol cock. And then I don't get my vintage petrol cocks leaking. But how do you make a seal like this on a lathe? Again, my little knife tool to the rescue. So I don't want to do this on the lathe because I'm scared of working around or doing videos with a knife on my lathe because I need to concentrate. But basically all that you do is you take some fuel line, you push it onto a bar. It needs to be quite tight so the fuel line can't move. You chuck the bar in the chuck, and then this knife tool, it just needs to clear the bar, and then you can actually part off all the various seals that you need. And then afterwards you just take it off and you have seals that are perfect on both sides, and they actually work incredibly well. Another thing I did the other day was I did the tires for my traction engine that I'm busy building. Again, this is something that I glued the outside. I had extra sort of conveyor belt on both sides of the tire, and then this was just stuck on a mandrel, and this parting off knife cutter was used to trim the edges. And this looks a lot neater than if I were to do it by hand. Incredibly, this tool gets used for making silicone seals for my sight glasses, for my steam locos. Any square O-ring, it does incredibly well. And the thing is, because some tubes are easier to find than very specific seals, you can match a material better to the whatever you want to use it for. So in other words, fuel line is easy to find, and then you can make seals that will work with fuel or oil. This tool's pretty handy.